looking at is molar mass, something a little bit new, something a little different. So if you guys want to open up your assignments for today, the introduction and practice to molar mass. If you guys want to open up that worksheet and have that ready to go, should look something like this. So we're going to be talking about a mole, and no, I'm not talking about a mole as far as an animal like the one in that beaker right there. We're talking about moles in terms of chemistry, which are going to be a little bit different. And so when we're talking about moles in chemistry class, we're going to be talking about basically the number of particles or the number of atoms in some specific mass. So specifically, 1 mole tells us this giant number right here. That 6.022 times 10 to the 23rd is the number of atoms that we represent with a mole. So a mole is just a shorthanded version of telling us that we have 6.022 times 10 to the 23rd atoms present in that specific amount of mass. So let's write that down, have that for us. So shorthand for saying there are 6.022 times 10 to the 23rd atoms in some specific amount of mass. And scientists came up with this basically just to make our lives a lot easier when we're thinking about these atoms and these particles. Going to those giant extreme numbers takes us a little bit too far away from the actual chemistry and actual what's happening. It makes us think more about values and how giant those things are, because that times 10 to the 23rd power means that we move that decimal point over 23 times to the right, which means we have just this ginormous amount of atoms. So saying 1 mole makes it a lot easier than saying, oh, I have 6.022 times 10 to the 23rd atoms of aluminum. Just makes our lives easier when we're talking about these things. And so these units, what are they actually used for? A mole is the only thing that we can compare between different elements and different compounds. A mole is the only way to compare elements and compounds, and that's why we need to be able to use it, especially in our lab, because it's the only thing we can use to compare from copper to aluminum or to silver or any other element or compound. We can't compare the mass of both of them because it doesn't tell us the same thing. So a mole is the only way we can compare different elements or compounds. And that's pretty much why we care about the mole. So we're not going to write anything new there, but we care about it because we like to be able to compare these things, especially when we're talking about chemical reactions, which is something we'll get to a little bit later. But when we're talking about this molar mass, we have to be able to find the molar mass. And so finding the molar mass is actually going to be a little easier than you think, at least at the start, when we're looking at elements, because we've actually already found it before, just using a different name. So if we look at our periodic table, and I'm just going to pick aluminum, because that is our problem we're working on next. So we're going to look at aluminum. We got aluminum. And if we're looking for the molar mass, we are going to be looking for the atomic mass. Can anybody tell me where the atomic mass is for aluminum?
13.
All right, that's our atomic number, which is perfect right up here. But the atomic mass is something a little bit different.
26.98.
26.98 is going to be our atomic mass, or that mass number. And I told you the molar mass is just something we already know, just with new terminology. Which means our molar mass, which one do you think it is? Is it the atomic number or the atomic mass?
Atomic mass.
The atomic mass is going to be what we use for our molar mass now. Perfect. So if we're looking at aluminum, the molar mass of aluminum, we're going to start with the molar mass of aluminum being 26.98. 26.98. But now that we're talking specifically about the molar mass, we have to go a little bit deeper and we have to add units. What are the units for mass that you think we're going to use?
KL.
Which one? What units?
Kilogram.
Kilograms is a perfect idea. In chemistry, because things are just so small, normally kilograms are what we use in science, but because chemistry talks about the itty bitty things, we have to go even further and we got to talk about grams instead, just because we use much smaller amounts than in kilogram form. It would just be a little too large for us. So grams, I'm going to write it out the first time, grams. And it's going to be grams of aluminum. So we have to make sure we're talking about aluminum here because we're talking about the molar mass. And this molar mass doesn't just tell us the mass of something, but it tells us the mass used to represent 1 mole. So if I shorthand the word mole, instead of saying M-O-L-E, it's going to be M-O-L. I know, really, really short for you. But we're going to have 1 mole of aluminum. So that 26.98 grams tells us how many grams it takes to represent 1 mole, or that 6.022 times 10 to the 23rd atoms of aluminum. How do we feel about that? I'm going to take that silence as we are wonderful. Ooh, perfect. All right. So now you have 2 more practice problems in group A. Find me the molar mass of copper. Find me the molar mass of potassium. Write them down. You got 2 minutes. Find those 2 molar masses. All right. Who found me the molar mass for copper?
63.55 grams of copper equals 1 mole.
All right, 63.55 grams. And I'm going to shorten up the grams of copper to just make it a little bit quicker for us. So it's G for grams. And we can even get rid of the word of altogether. So we're just going to put the copper Cu equals the 1 mole of copper. Perfect. Last but not least, we have the molar mass of potassium. Who found that one?
39.10 G of potassium.
Grams of potassium equals 1 mole of potassium. Perfect. All right. I'm going to take it one step further because we're writing this in one of the two ways we can write out molar mass. This way is perfectly fine. It helps us in the future, which is why I like to write it out this way. But there's also a second way we can write molar mass that does help us a little bit, makes it a little bit quicker for us again. So whichever way you want to keep writing it, go for it. It's correct either way. But this is going to be what we call a conversion factor. And other conversion factors you might be able to think about are there are 12 inches in 1 foot. There are 100 centimeters in a meter. There are 4 cups in a quart, that kind of thing. Those are conversion factors that you may or may not just know off the top of your head. These are going to be conversion factors for when we try and go from grams to moles or moles to grams, which is going to be later in this unit. But the other way we can write it to shorthand those units just again is going to be 26.98 grams per mole of aluminum. And so that slash tells us that it's like a division sign. So it's grams divided by moles, or there are 26.98 grams in 1 mole of aluminum. So these are the exact same. You could write it either way. But just in case, I'm going to write them both on all three. So 63.55 grams per mole of copper and 39.10 grams per mole of potassium. Both are very acceptable. Both are wonderful. Use whichever one you want. Perfect. I like it. It's a party now. Now we got to go to example group B, where we're going to get a little bit more difficult. Not too much more yet, trying to keep it a little bit easy still. But if we go down here, we're going to have to follow 3 simple steps, and they're not terrible. But the first step we're going to follow is we are going to find the molar mass of each element. So we are talking about compounds now. So we have potassium and chlorine as KCl. We're trying to find the molar mass of that potassium chloride compound. So the first thing we're going to do is we're going to find the molar mass of potassium and chlorine separately. Okay, NCl. So if we look at our periodic table, what is the molar mass of potassium?
39.10.
39.10, perfect. And chlorine?
35.45.
35.45, because chlorine's over here. So let's write them down. We had 39.10 and we had 35.45. We are done with step 1. We're one step closer to being done with this problem. Step number 2 is going to be multiply the molar mass by the subscript. All right. So when we do that, we need to multiply each element by its subscript. So if we look at this first one, potassium, how many potassiums do we have here?
1.
We have 1, since there's no number right here that tells us it's a 1. So we take this, we're going to multiply it by 1. And what about chlorine?
1.
We have 1, so we're multiplying it by 1. And so when we multiply things by 1, it does stay the same. So you can leave that off, or you can do it whichever way makes you remember to multiply those subscripts. And we're just going to bring them across, 39.10 and 35.45. And now our third and final step is going to be add the molar masses together. So we're going to take these two and we're going to add them together. And what do we get when we add those two together? All right. Move that up. Perfect. 78.04. And what else do we have to do when we do this, when we add those together?
Put the gram mole thing.
Perfect. Grams per mole of potassium chloride, or we have 78.04 grams of potassium chloride equals how many moles? One mole. Perfect. Any questions on those steps? All right. Do you guys think you can try the next two? Go ahead and try the next two. Take about 5 minutes this time to try the next ones. Then we'll come back as a class again. All right, ladies and gentlemen. So let's take a look at those next two. We had sodium sulfide. So then we find the molar mass of sodium or sulfur.
Sulfur is 32.07 times 1.
Perfect. And we multiply it by 1. And the other one is 22.99. Perfect. And do we have to multiply that one?
Yes.
We do. So we're going to multiply that one by how much?
1. Oh, wait,
For
no,
that
that's
one, we're going to multiply it by 2 for sodium because we have a 2 right here. Perfect. And we don't have to multiply it by anything but 1. So this one we just rewrite as, as 32.07. And what is 22.99 times 2?
$45.98.
Perfect. All right. And if we add these two together, what do we get? All right, 78.04. And what are my units here?
I didn't catch that.
Grams. Perfect. We have grams of sodium sulfide equals how many moles?
1.
1 mole. Perfect. Sweet. All right. Next one. Aluminum oxide. We have to find the molar mass of aluminum and oxygen. Who found either of those?
$26.98.
Awesome. And we have oxygen.
$15.99.
Perfect. 15.99. I think on some years it does say 16. I like to leave it at 16 just because it makes our lives easier. And do we need to multiply either of them by any value?
Yeah.
All right. What values am I multiplying?
Aluminum by 2 and oxygen by 3.
Awesome. All right. What do I get when I do 26.98 times 2?
53.96.
All right. What do I get when I do 16 times 3?
48.
Awesome. Now I'm going to add them together, and what do I get?
101.96.
Can you repeat that?
101.96.
101. Perfect. Perfect. And any units on that one?
Grams.
Grams. Aluminum oxide equals what?
1 mole.
Perfect. All right, we just crushed Group B. We got one more group, Group C, and then we're done for the day. 3 more example problems.
I have a question.
Yes.
is it always gonna like be 1 mole?
The molar mass always equals 1 mole, yes.
Okay.
All right. Any other questions before we continue? Great question. All right. So the group C is going to be our hardest group, and it's the hardest one because it has how many elements?
3.
It's got 3, so we have to do it 3 times instead of 2. Just makes it so much more difficult. So let's go through this first one together. We have lithium sulfate. Somebody tell me one or all of the elements.
Lithium, sulfur, and oxygen.
Awesome. Lithium, sulfur, and oxygen. We need to find those molar masses. We're following those same steps as before. Find the molar mass of each of those 3. Who knows one of them?
Lithium 6.94 times 2.
We gotta multiply it by 2. All right. Sulfur or oxygen?
32.06.
Awesome. Oxygen?
15.99.
15.99. I'm gonna keep it at 16 just to make my life easier. Do we need to multiply that one?
By 4.
By 4. Perfect. All right. We multiply 6.94 times 2. What do we get?
13.88.
32.06. Stays 32.06. 16 times 4.
64.
64.
64. Awesome. All right. Let's add those 3 together now.
$109.94.
Do I have units?
Grams.
How many moles does it equal?
1.
1 mole. Perfect. All right. Nice work. All right. You guys have 2 more example problems. I do